So just to pick this up from the previous part, this slide right here deals with the chloride secretion and crypt cells of the colon and in the salivary glands, the acini there. So the important part here is to pay attention to the chloride transport, and we're using a CFTR channel. So now here's your summary on secretion. Basically, here are the items that need to be secreted. It will be digestive enzymes that are secreted into the mouth, stomach, and the intestine. Then the mucus cells in the stomach, and the serous cells in the salivary glands, the goblet cells in the intestines, they all secrete mucus or mucins. And so saliva is an exocrine secretion. And of course, the liver also participates with the secretion of bile. So bile salts, bile pigments, cholesterol. The gallbladder only acts to store and concentrate the bile juices. So you can actually get rid of your gallbladder if it bothers you. It will be no harm to get rid of this. Here's some more information about the liver and the gallbladder. The liver is very large. It's here weighing in at 1.5 kilograms or 3.3 pounds, which is sizable as an adult liver organ right here. It's just under the diaphragm and toward the right side of the body, and here would be the gallbladder embedded right there. So we have this common bile duct right here. The liver is secreting most of the bile, and then here this is kind of a storage place. But sometimes gallstones form right in here, and it bothers you. It hurts pretty bad, so it's no harm to remove this. You're going to have enough bile juices coming from the liver, actually. And here, focus on the liver. So this would be a liver lobule. These hepatocytes right here. You have an extremely leaky epithelium right here, or capillary bed. And so you're filtering all the stuff that was absorbed from the gastrointestinal tract will have to be first checked through the liver. And so your liver is very meticulous in checking everything out that you have absorbed. So everything is run through these hepatocytes and is being checked out. And if necessary, you're going to detoxify. So here, some more focus on the liver, what all the wonderful things that the liver will do. So here is sort of in the center, the liver right here. It's responsible for glucose and fat metabolism, protein synthesis, hormone synthesis, urea production, detoxification of all sorts of things, and storage of stuff such as glycogen. And sort of here what comes in from the hepatic portal vein. These are all the absorbed items from the gastrointestinal tract. Now what's leaving from the liver via the bile duct would be these bile salts, bilirubin, water, ions, and phospholipids. And then over here, metabolites and drugs from the peripheral tissues, they go into the liver. And here, so some items, bilirubin, metabolites, hormones, and drugs, nutrients. And what's leaving here via hepatic vein with metabolites to the peripheral tissues, and it includes all the stuff that has been checked by the liver, such as glucose, plasma proteins like albumin, clotting factors, urea, vitamin D, metabolites, some other stuff. Okay, so let's take a look at the small intestine and the villi. Those are massive surface area extensions that are increasing the surface area for maximum absorption, because the main purpose of the small intestine is absorption. So you want to digest and then absorb. So you're creating these finger-like projections, and they are lined here with epithelial cells. There's some goblet cells that produce mucus, and then all sorts of cells that are producing different items. You also have the brush border. These are microvilli. These are cellular extensions that then even increase the surface area some more. Now let's take a look at how these food items are actually digested in your gastrointestinal tract. So let's start with the carbohydrates. We have polymers of single sugars or simple sugars. And so we have starches such as glycogen, potato starch, cornstarch, you name it. So these are polymers of simple sugars. We're using the enzyme amylase to break them down to smaller and smaller subcomponents until we're arriving at monosaccharides. That's what you want. So you have First, you would have disaccharides and then eventually monosaccharides. That's what you want. So glucose, fructose, galactose, these are all monosaccharides that then can be absorbed. Here's how the absorption happens in the small intestine. So here we are in the lumen of the intestine, and we have just digested some starch, and we have now simple sugar, so we want to transport it into the capillary here, into the blood. And so we're going to transport, here's a sodium glucose co-transporter, or the fructose enters versus another glucose 5 transporter. Either way, these simple sugar molecules, they'll be transported across the entire epithelium. So this is transepithelial transport from the lumen of the intestine into the capillary, where they are then transported to the cells that need these sugars for energy. Proteins need to be digested into simple amino acids, and so we're starting out with long polypeptide chains, and we need a variety of different peptidases to digest our proteins. It's not a simple thing, it's not a one-step process. You need a variety of different kind of enzymes that will break down your protein into simple amino acids. So we have endopeptidases. Anytime you hear the term peptidase, it's a protease. That's a protein digesting enzyme. Here are some more examples. Pepsin works in the stomach. That's definitely a protease. Then we have trypsin and chymotrypsin in the small intestine. All of them start nibbling away on those proteins. You have aminopeptidases and carboxypeptidases that are starting from either the carboxy end, if it's a carboxypeptidase, or from the amino end, if it's an aminopeptidase. And so they're chopping down these proteins from the various ends. And in the end, you're going to have simple amino acids. So here will be an amino acid, here's another amino acid, and then you need to absorb that. And it's kind of a similar process to the carbohydrates. The absorption of these amino acids needs to go through transepithelial transport. And so we're going to go through the entire epithelium right here and enter the blood. And then off we go to the liver for double checking that what we just absorbed is actually okay. Now, the digestion of fats is a little bit more complicated because all of our enzymes are water soluble, and water and lipids don't like to mix. So what do we need to do? We need a emulsifier. We need to break down the fat into smaller chunks to increase the surface area so that our enzymes can actually work on the surface. And for that, we're going to need bile. Bile juices, or bile in general, that's a good emulsifier. And it basically increases the surface area of the lipids, and then the enzymes have an easier time to work on those lipids, on the fats, and digest the fats. Once we have an increased surface area, then those enzymes, mostly it's lipase and co-lipase, they will digest the triglycerides, it's your dietary fats. Here you have glycerol backbone, and then 3 fatty acids, so tri for 3 fatty acids, and glyceride, this is your glycerol backbone. And lipase and co-lipase, they will do a good job in digesting down your triglycerides into free fatty acids. You have free fatty acids here, and then the glycerol is actually a carbohydrate. Here is a picture of micelles. A micelle is actually one of those smaller droplets that were generated with the help of emulsifiers such as bile juices. And so with the help of bile salts, you're generating these small droplets, and then your enzymes have an easier way to digest the fats into fatty acids and glycerol. We're taking a look at the fat digestion and absorption. So here's your fat, large fat droplets, chunks of fat that you've eaten. And here comes your bile salts, and we're creating these smaller droplets, these micelles, that create a higher surface area. And now we can start working on this, and we're using lipase and co-lipase to digest our fats to free fatty acids. Now, we also have the cholesterol backbone. So here would be, the glycerol backbone. So we need to deal with the glycerol, and that's actually a carbohydrate. So anything that's non-fatty acid will be absorbed and eventually into the capillary of the blood. So right here, everything that's lipid soluble, and this is important, the lipid-soluble stuff needs to be transported across the epithelium, but it will enter a lacteal. Why a lacteal? Good question. I don't know. So for some reason, fatty acids and lipid materials in general, they will be absorbed into a lacteal, which is a lymphatic vessel, which then bypasses the liver, and it will return its fluids back into on the venous side of the circulation, just right around the area of the venous, the subclavian vein. So why that is, I'm not sure. For some reason, your liver doesn't want to see the fatty acids or lipids in general. Everything that's non-lipid ends up in a capillary. So there we are right here in the capillary. But fats and lipids in general are absorbed into lacteals. And please take a note of this. This is important. Fatty acids are absorbed into lacteals, and they will be transported to the vena cava, bypassing the liver. For some reason, your liver doesn't want to see that stuff. Now here, let's finish up with digestion and absorption. We left out one group of macromolecules, and that would be nucleic acids, so DNA and RNA. They are digested down into nitrogenous bases and monosaccharides, the ribose or deoxyribose, and that will be absorbed in the intestine, along with vitamins and minerals. Anything that's fat-soluble is absorbed as fats into lacteals. Any water-soluble vitamins are absorbed by mediated transport. An example here, vitamin B12 is absorbed by complex to intrinsic factor only. So people that lack intrinsic factor, they will not be able to absorb vitamin B12, and that's a problem. Mineral absorption usually occurs by active transport, so there will be iron, calcium, and some other minerals that we need. Sodium is absorbed by enterocytes and colonocytes. Here's an image that shows you the iron absorption. So here's the lumen of your intestine. You want to absorb the iron, and we need it, so we want to put it into the extracellular fluid and eventually in the blood. And you don't need to know details about this. So let's move on to calcium absorption. And here again, just an overview here on the calcium absorption. We want it to move from the lumen of the intestine all the way into the blood eventually. And so there's some regulatory items here regulated by vitamin D3. So calcium absorption is regulated by vitamin D3. Here's an image showing you the sodium, potassium, chloride, and water absorption from the lumen of the gastrointestinal tract to the extracellular fluid compartment. And you don't need to know the details of these different pumps and pathways. It's not really necessary. So just take a look at how all of these items are being transported across epithelium. So transepithelial transport. Now we're moving on to regulation of gastrointestinal function. We do have these long reflexes that are integrated in the central nervous system. The short reflexes are integrated in the enteric nervous system, and the reflexes involve gastrointestinal peptides. So we're going to take a closer look at these GI peptides. Here's an image showing you the integration of digestive reflexes. I feel like that this diagram here is more complex than what the whole thing is worth. So couple points to consider here. Smooth muscle and endocrine cells of the stomach, pancreas, intestine sort of take a central role right here. You really don't need to know all of these flow charts and what leads to another thing, but so these digestive reflexes, there's various ones of them. Maybe most importantly, the regulation of how to move forward. So if you just squirted some amount of acidic stuff from the stomach into the duodenum, you want to make sure that you don't squirt too much, and so your small intestine will send some feedback and say, hey stomach, just don't give me anything right now. I need to first work through the stuff that you just sent, and then you can give me more after that. So pretty much just like that. Now the enteric nervous system does share features with the central nervous system. We do have intrinsic neurons, we have neurotransmitters and neuromodulators, just like in the CNS. We have glial support cells, diffusion barriers, and an integrating center, so it's all very similar. And finishing off this part here with some digestive hormones that you will need to learn about and know. Those, the gastrin family, gastrin and cholecystokinin, CCK, the secretin family, we'll take a closer look at that. and then also some others like a motilin, and you will learn more about that in the next section.